All right, this is homework number 7, the review for the first test. We're going to go over it, make sure you understand how to do each problem. So, some of the questions are going to ask you to match an inequality or interval notation to a graph. So for the first one here, we have to notice certain things: closed circle, open circle. Okay, so we have the numbers that are greater than -3 and numbers that are less than 5. So this inequality we're going to write in our between statement. -3 is less than or equal to, because we have a closed circle, x, or any variable you want, less than, because there's an open circle, 5. And our interval notation would be a bracket for the less than or equal to on the -3 and the 5 and a parenthesis. Number 2 is numbers that are less than 4. So x is less than or equal to 4. So this one starts at -infinity, so parentheses -infinity, comma 4, and a bracket for the closed circle less than or equal to sign. Number 3, the whole number line is shaded, so it's all real numbers. Set notation looks like this, with the curly braces, x, such that x is contained in the set of all real numbers. And the interval notation is from -infinity to +infinity. And then the last one, we're going to notice both of them are open circles. It's less than 1, so x is less than 1. Or, because you can't be in the same place, in both places at the same time, x is greater than 4. And so that's -infinity, comma 1, or with the u, parentheses 4, comma +infinity. And that is our interval notation. Now we'll look at solving some absolute value equations. Remember that absolute value is the distance from 0. So we have 7 equals the absolute value of 1/2 x plus 3. And so we're going to write two equations. The 1/2 x plus 3 equals 7. I can switch where the variable is. And 1/2 x plus 3 equals -7. So then we'll solve this. Remember, what's inside could equal a +7 or a -7, and both would end up having a final answer of 7, which is why we get two answers. There's only one time we get one answer. So 1/2 x equals 4, 1/2 x equals -10. And to get rid of 1/2, we multiply by the reciprocal, times 2, times 2. So x equals 8 and -20 for number 7. I'm sorry, for number 5. Number 6, 4 minus 6 times the absolute value of n over 3 minus 1 equals -8. Now you can't rule anything out as no solution until you have gotten the absolute value by itself. So we're going to subtract 4. We cannot add these two. I saw a lot of trying to put these together. They cannot be put together. The 6 is being multiplied, the 4 is being added, so we're going to subtract 4 from both sides. We get -6 times the absolute value of n over 3 minus 1 equals -12. And divide by -6. The absolute value of n over 3 minus 1 equals 2. This is this critical step. Okay, too many of you get lazy and don't write it with the absolute value by itself, and then you just start writing your two equations. We need to write this step so that we can see whether or not we're at that no solution, all real numbers type situation. So here we have the absolute value equals a positive, so we'll write our two equations, not an issue. So n over 3 minus 1 equals 2, and n over 3 minus 1 equals -2. And you can add 1, n over 3 equals 3, and n over 3 equals -1. And to get rid of the 3, we're going to multiply by 3 over 1. And so n equals 9 and -3. That's our answer for number 6. Okay, I'm going to just clear off the screen and do the next one. always rewind and look over those again. We'll make some room here so it doesn't get as crowded. So we have number 7, -3, absolute value of y plus 8 equals -24. Now again, we can't make that determination about whether it's no solution until the absolute value is by itself. That -3 is being multiplied, so we're going to divide by -3. Y plus 8 equals 8. Well, that can happen. So y plus 8 equals positive 8, and y plus 8 equals -8. Then we can subtract 8 from both sides, and we get y equals 0, and y equals -16. It's okay to get 0 as your final answer. It's also okay to get a negative as your final answer. So number 8, 13 equals the absolute value of 4x plus 7 plus 13. I'm going to get 13 on the other side, so 0 equals the absolute value of 4x plus 7. At this point, it can't be -0, so this is the only time I get one answer. 4x plus 7 equals 0. 4x equals -7. And x is -7/4. That's number 8. The only time you get one answer is if it equals 0 when the absolute value is by itself. Okay. So number 9. Absolute value of k minus 15 plus 7 equals 3. Subtract 7. Absolute value of k minus 15 equals -4. So we're going to, remember, this is that critical step. And the reason it's so critical is because if you keep going and just start writing your two equations, you miss the fact that we have an absolute value equal to a negative, which means there is no solution. And that's your final answer. Because an absolute value always comes out positive, therefore it can never equal the negative. So I have the absolute value of x plus 4 plus 1 equals -x plus 2. Now when we have variables on both sides of the absolute value equations, that's when we really need to check for extraneous solutions. So first I got to get the absolute value by itself. Absolute value of x plus 4 equals -x plus 1. And now I'm going to write my two equations. X plus 4 equals -x plus 1, the exact equation there. And my second one is x plus 4 equals the opposite, -x plus 1. So that becomes x plus 4 equals x minus 1. Now I'm going to solve this. So we're going to add x to both sides. And we get 2x plus 4 equals 1. Subtract the 4, 2x equals -. So we get x equals -3/2. And we solve this one when we subtract the x. We get 4 equals -1, which means there's no solution on that one. So now we need to make sure that this one works, the -1.5. So absolute value of -1.5 plus 4 plus 1 equals -1.5 plus the 2. So this becomes plus, so this becomes 3.5. And here we get 4 minus 1.5 is 2.5, plus 1 is 3.5. So that one worked, and our only answer is -1.5. Okay, so those are those problems. Let's look at the next set. Solve each compound sentence and graph the solution set. Show all critical steps. So show all your work. N over 2 plus 1 is greater than -6, or 8 is greater than 4n. So subtract my 1. N over 2 is greater than -7 times by 2. N is greater than -14. I multiplied both sides by +2, so I do not flip the sign. Here I'm going to divide by 4. and I get 2 is greater than n, or n is less than 2. The sign has to orient the same to the number. So if the open side is towards the 2, when I flip it around, the open side needs to be towards the 2. And so let's graph this on a number line. I have, this is an or, n is less than 2 and greater than 14. And when it covers the entire number line, it's an or. They're going in opposite directions. Or is all of the shading. The answer is then all real numbers in set notation. It looks like this. Number 12, negative 28 less than or equal to 5k minus 3 less than negative 3. So to do this one, we're going to get k by itself on the middle, and whatever I do to the middle, I do to both outsides. So we get negative 25 less than or equal to 5k less than 0. Then divide by 5. Don't forget that 0 divided by anything is 0. So we get negative 5 less than or equal to k less than 0. We put that on a number line. Close circle on the 5, open circle on the 0, greater than 5, or greater than negative 5 less than 0. Number 13. We have negative 2n plus 6 is greater than 10, or 3/4 n minus 1 is greater than 5. So we're going to subtract 6. Negative 2n is greater than 4. Divide by negative 2. And n is greater than negative 2. Nope, not greater than. It's divided by negative 2, so less than negative 2. Or, here we're going to add 1. We get 3/4 n is greater than 6. And we're going to multiply by 4/3. Multiply by the reciprocal when there's a fraction. And that's n is greater than, 6 times 4 is 24. 24 divided by 3 is 8. So let's look at that on a number line. We have negative 2, open circle, less than, 8, open circle, greater than. And it's an or, so that looks about right. Let's see, number 14. I know you can't see it on your screen. I have it open on a different screen. I have this is not it. Okay, sorry. We have 3y is greater than 12, and negative 5 is greater than y plus 6. So we'll divide by 3, so y is greater than 4, and remember with and we're looking for solutions to both, so that is why it's important to bring the word down so you know what you're looking for when you're looking at that number line, looking for the weird cases. Subtract 6, negative 11 is greater than y, so y is less than negative 11. So this is an and. Oops. Draw my number line. Negative 11, open circle, less than, 4, open circle, greater than. Well, and is looking for the overlap, and there is no overlap, so this is no solution. And number 15 is 4 minus k is greater than negative 12, or negative 5 is greater than k plus 6. So we are going to subtract 4. We get negative k is greater than negative 16. When it's negative k, you have to divide both sides by negative 1, and the inequality flips, so k is less than positive 16, or subtract 6 again, negative 11 is greater than k is less than negative 11. So here we have negative 11 less than, and 16 less than. Well, when I shade the less than 16, it covers everything less than a negative 11, so it's redundant to say both. And in our final answer, we just need to say, not y, k is less than positive 16.